Today I'm going to talk about another important aspect of logic, which is negation. Negation. So the negation of a statement is the statement, it was when you say that that statement isn't true. So the negation of P, of a statement of P, is P is not true, which we sometimes write as just not P. So if you were having a rather odd kind of argument with someone and you wanted to say that what they were saying is not true, you might say P is not true, or you might say not P! Right. So what does this mean? For example, if I said, let me tell you some things that are blatantly untrue so we can see what's going on. For example, here's a statement that's blatantly untrue. I am always hungry. Okay, clearly I'm not always hungry. When I've just eaten my dinner, I'm not hungry anymore. So this is not true. And what's another way of saying that? Well, you might accidentally think that to say that is the same as saying I am always full, but that's not true either, because sometimes I'm hungry. So to show that this is untrue, all I have to demonstrate is that sometimes I am hungry. Sometimes I am hungry. So another example is something else that's blatantly untrue. Strawberries are better than raspberries. That is not true. Well, why isn't it true? Because what does that mean? It's just a stupid statement, really. It doesn't make any sense. Maybe some people think strawberries are better than raspberries, but some people think that raspberries are better than strawberries. So the fact that this isn't true isn't necessarily shown by saying raspberries are better than strawberries, but all you can say is that strawberries are not better than raspberries. Are not. Raspberries. So let me try and turn this into a more precise statement. Here's another example. Supposing I tell you the following blatantly untrue statement. All cats are black. All cats are black. That is blatantly untrue. So what would you have to do, supposing I absolutely insisted that all cats really were black, what would you have to do to show me that I was completely deluded and, in fact, it's not true? Well, you'd have to show me that there was just even one cat somewhere that wasn't black, right? One would be perfectly enough to show me that I was deluded. So all you have to do is say, there exists a cat who is not black. So notice very carefully that the fact that I was claiming something about all cats meant that you had quite an easy job. All you had to do was produce one cat that contradicted my theory. Now, if I claim something less broad like that, but still completely false, supposing I claim, I'm going to claim to you, there exists a purple cat. There exists a purple cat. Do you think that's untrue? Is not true. What would you have to do to show me that there was not a purple cat anywhere in the world? Would it be enough for you to produce one cat? that wasn't purple? No, it wouldn't be enough, would it? You would have to demonstrate that every single cat anywhere in the world was not purple. Because if you just produced to me 1 cat, or even 100 cats, or even 25 million cats that were not purple, I might still say to you, well, you know, there's one that's purple, and you know, perhaps I've got a cat who has walked into a pot of purple paint and who is in fact purple, and there's just one of them. So no matter how many other cats you produce who aren't purple, that's just not going to help, because I've still got one who's purple. So in order to show me that there really does not exist a purple cat anywhere, you would have to demonstrate all cats are not purple. So notice very carefully that in this case, I was just claiming that there existed a cat, and you, to demonstrate me wrong, had to show something about all cats, which was much more difficult. In the first case, it was much easier, and in the second case, it was much more difficult. So this is a very important fact about mathematical statements, that if you want to produce the negation of something, then you have to switch the for alls and the there exists. So the negation of for all x, p is true. Now this for all sign is an upside down capital A. I have a feeling it didn't come out very well in the earlier video. So the negation of that is there exists x such that not p. This means there exists, and it's a backwards capital E. And similarly, the negation of there exists x such that p, the negation of that is for all x not p. So have a little think about those and make sure you understand why for all negates to exists not, and exists negates to for all not. Right, so much for all and there exists. What about implication? Well, maybe before we do implication we should do and or. That's a good idea. Let's do and or next. So what's the negation of, let me try telling you something that's blatantly untrue. I am hot and I am cold. I am hot and I am cold. Well, that's blatantly untrue. The reason, well, I'm not sure that's a very good example, actually. Let me try a different example that's even sillier. I am green and I am purple. Right. That is blatantly not true. And to show, I'm going to ditch that example. To show it's not true, what do you have to do? Well, all you have to do is demonstrate either that I'm not green or that I'm not purple. Because if even one of those things fails, that means I'm not green and purple. Okay, so you can demonstrate that I'm not green and I'm also not purple, but that would be overkill. So what that means is I am either not green or not purple. So the negation of P and Q is not P or not Q. So notice how this and turned into an or there. And very quickly, because my time is running out, I'll write on the board that the negation of P or Q is what? Well, perhaps I'll leave that for you to think about before the next video.